Hello, here we go for the last video for chapter 13. We're talking about relationships between lines now. Okay, for section F, we looked at intersecting lines. So now let's talk about, we can go back to thinking about linear functions even, way back when. There's three different ways that 2D lines can intersect. Either they're going to intersect with one point of intersection. Okay, so here we have only one point of intersection, or they can be parallel, so no points of intersection, no intersection, or the lines could be exactly on top of each other, which is called coincident, means they are essentially the same line. That's an infinite number of intersection points. Okay, so those three situations are the only situations that can exist about two intersecting lines in 2D. And now, if we're in 3D lines, there's two different things that could happen with 3D lines. Either they could be coplanar, which means they exist in the same plane, the same 2D plane, or they could be skew, which means they are in a 3D space and they will never intersect with each other. So if they're coplanar, then these same three situations can exist, even though they're a 3D line. These same three situations exist because they share the same plane as each other, even though they're 3D. If they are skew, however, they will never meet. But we will find an intersection point between them because we will move one to be near the other. We won't change any other thing about it. We won't change the direction it's in. We'll just move it so that it will intersect with the first line. Okay, similar to when we looked at vectors way back when, and we had one vector here and another vector over here. We wanted to find the angle between those two vectors. Then we just took this vector and moved it over here to begin at the same place as the first vector, and that's the angle that we found. Same thing will happen with skew lines when we're finding the angle between them. We will just move one to be intersecting with the other, and that's the angle that is assumed to be between the two lines, even though they are skew. Okay, so let's take a look at some sort of work that we may have to do in this section. Relationships between lines, classifying lines. Okay, example 15 from your textbook gives us three lines. We have line 1, and line 3, so three lines in 3D. Show that lines 2 and 3 intersect and find the angle between them. So lines 2 and 3 show that they intersect. So when we're showing intersection or figuring out where the intersection is, remember the x coordinates must equal each other, the y coordinates must equal each other, and the z coordinates must equal each other. So let's take line 2 and 3. Let's equate the x coordinates. Equate the y coordinates. And equate the z coordinates. And we have three equations with two unknowns. We really only need two equations with two unknowns to solve them. So let's choose the two easier ones to work with. I'll choose these two, call the first one 1, and rearrange it. 2u plus t equals 0, and u plus t equals -1. Okay, so that's equation 2. We can subtract these right away to eliminate the t's. So we'll have u equals 1. Okay, then we can take u, fill it in here in each of the u spots so that we know we will have xyz equals 1 plus 2 times 1 3 minus 2, 7. Okay, let's check our answer. We have time. Let's check. Solve for t. So I'm going to take this and substitute 1 in for u. Solve for t. T equals -2. And let's just check t then. Just make sure it's the same answer as this one. Minus 2, 7. Yeah, so that point of intersection is here in that ordered triplet. 3, -2, 7. Okay, and find the angle between them. Okay, so when we find the angle between them, all we need are the direction vectors. Direction vector. So we're finding the angle between line 2 and 3. So cos theta equals direction vector of 1, well, and line 2 actually, direction vector line 3. These are lines, so we need this notation. Okay, I'm going to calculate these by themselves. So let's do dot product of the direction vectors. Direction vector, and we'll take this absolute value of it. Direction vector for line 2 is -1, 1, -2. I'm dotting that with direction vector from line 3 to -1, 3. And I'm going to find the absolute value of that. So -2, subtract 1, subtract 6, absolute value, -9, absolute value, which is 9. Okay, so that numerator is 9. Now we'll find the size of the direction vector of line 2. Make a separation here. Don't get mixed up. There we go. That's root 6. And the size of the direction vector from line 3. And that's root 14. Okay, we go to our calculator. Theta equals cos inverse of this guy. Calculator. in degree mode, so my answer will be in degrees. $10.9. Is that the right answer? Yes, it is. 10.9 degrees. Okay, so that's the angle between the two lines.